Hello folks, welcome to another important video, verification and validations. So what is the difference? Two words that sound similar, but in automotive, confusing them can delay programs, increase cost and create quality issues. In this video, I'll explain the difference between verification versus validation using real world automotive examples in a way that actually makes sense. So let's start with a very simple definition. Verification asks, did we build the product right? Validation asks, did we build the right product? This one sentence explains already 80% of the difference. Verification focus on requirement compliances. In automotive, verification means checking dimensions, checking specifications, checking tolerances, and checking interfaces. For example, does a bracket match the drawing? Does the part meet the material specs? Does the connector pinout match the requirement? Verification is usually design based, specification driven, often done early and frequently in the program. In automotive, validation means, does the system work in the vehicle? Does it survive real conditions? Does it even meet the customer expectations? So let's take few example. Does the headlamp perform in rain and fog conditions? And does the component survive the vibration, the heat that is expected in the market? Does the vehicle behave as expected during driving? These are usually the customer voices. Validation is usually use case driven, environment driven, and perform later in the program. So let's take a very simple example, a headlamp mounting bracket. So the verification methods may be design, does the dimension match the drawing? Does the material grade is correct, or the whatever the fastener torque we have decided, is it meeting to the spec? So these items normally called as verification methods. When it comes to validation, it has answers like the headlamp stays aligned during driving, so there is no vibration noise, no failure over vehicle life. So you see the difference, it's the same part but two different questions. These check items in validations are customer voices. So now let's place this in an automotive timeline. Okay. So verification starts early and happens during design and developments through virtual verifications with CAE, continues through production with physical verification. The validation starts once the physical parts exist, okay, and peaks during the first builds, design validations, and proto validations phase or production validation phases. So this confirms the real world performance. So the verification is continuous and the validation is milestone driven. So some like a few programs which often fail. What are the mistakes a program can make? So sometimes the verification is complete, but the validation is weak. So we are not able to capture the customer voice. The component is passing the drawings as we design, but it's failing the durability itself. It's meeting the specs, but missing the customer expectation itself. So, so in simple word, passing verification does not guarantee your validation success. So to summarize, The verification answers, did we build it right? Okay, or did we check it right? It's spec driven and it is continuous. Whereas validation asks, did we build the right thing itself in the first place? It's use case driven, it's milestone based, and understanding this difference makes you a very strong automotive engineer and makes your automotive program a success. As also, automotive also follows the PD cycle, that is plan do check act. Any market feedbacks or any new market needs are translated into first the customer voices, which are the validations, and this, based on this validation needs, the verification methods are developed. So you see, the verification methods or the validations are improving with each program wise the program. So with this we come to the end of this video. If this explanation helped you, subscribe for more real automotive concepts explained very simply. Till then, please stay tuned.